A convex pentagon ABCDE has side lengths AB is equals to 5, BC, CD and DE as 6 and EA as 7. Moreover, the pentagon has an inscribed circle. Find the area of this pentagon ABCDE. So if I consider a circle and if I draw a pentagon, so let's say these are points of tangency, and so we are having pentagon something like this. So the third point if I take here, and the fourth point somewhere here, and fifth point somewhere here. So I'm having a pentagon something like this. So let's say this is A, B, C, D and E. So now like if we consider this length, so length of the tangent from A, there are like two tangents, they both must have same. Similarly from D also, like if I consider this as X, this will be X, because if we are having a circle and if we draw two tangents, those tangents must be of equal length. So if that is X, similarly if I consider like this as some Y. Now we know that the DE length, so we were given that AB is 5 and BC, CD and DE, so they are 6 and EA is given as 7. So if BC, so if we consider like BC and CD must be same and CD and DE also must be same. So that means this must be Y. Now if this is Y, this will also be Y because it is the length from outside point onto the circle. And now like this BC is equal to CD, so therefore like if I consider these points, let's say these points are P, this point is some Q, this point is some R, S and T. So CQ, BC is nothing but X plus Y, so that means BQ will also be X. So in the similar way, if we consider this as some Z, this will also be some Z and BP will be X. So that means I'm having the equations X plus Z is 5, X plus Y is 6 and Y plus Z is 7. So if I add like X plus Y plus Z is 9, so that means I'm having Y plus 5 is 9, so that means Y is 4. Similarly X plus 7 is 9, so that means X is 2 and Z plus 6 is also 9, so that means Z is 3. So we found the values of this X, Y and Z values. So now like if we consider the incenter as some I, so if I draw this, so this will be perpendicular and we are having a right triangle. So in the similar way, like if we consider, suppose let's say any right triangle, suppose like if I consider this IQ and B. So if we consider this IQB, if I consider this as some alpha, in the similar way, like if I consider this another triangle here, so which is ISD, so this will also be alpha because these two triangles are congruent. And we can say they are congruent because we have this IQ being the radius. So IQ is nothing but IS because they are all radiuses in radius of this pentagon. And we are also having this QB is equals to SD because QB and SD are both equal. And we are having this IQB is equals to ISD being 90 degrees. So that means by using like SAS congruence, I can say that triangle IQB is congruent to ISD. So that means if this is alpha, if BIQ is alpha, then SID will also be alpha. So in the similar way, we can also see like suppose the another set of another set of like congruence triangles. So if I consider like CI and R, so we can say this is 90 and we are having this base as Y and the in radius as IR. Now that is equal to, if I consider another triangle here, let's say. So even like ISE is also having the same thing. So that means we can also say like triangle CIR is similar to triangle SIE. So that means if I consider like this as some theta, this will also be some theta. So now like if that is theta, so this will be 90 minus theta and this will also be 90 minus theta because if we are having a circle and if we are drawing like two tangents, so then if these two triangles are congruent triangles, so if this is alpha, this will also be alpha. in our case, like we're having this as some 90 minus theta. So that's why like even this one will also be 90 minus theta. So that means if I consider like this as some alpha, so this will be 90 minus alpha and this will also be 90 minus alpha. So that means this angle will be 2 times alpha and this angle will be 2 times theta. So that means if I elongate this points, let's say this is some point N and let's say this is some point M. So now like we are having, so even here as well, like if we are having, this will be 90 minus alpha. So if that is 90 minus alpha, so if we join this, this will also be 90 minus alpha. So making this thing as 2 times alpha. Similarly, this will be 90 minus theta. And if we join this one, this will be 90 minus theta. So this will be 2 times of theta. So that means if we take these triangles, BMC and this EDN, so these two triangles. So these two triangles are having like same angles. That means these two triangles are similar. But most importantly, we can say that this angle is equal to this angle, because in that particular triangle, we're having the other two angles are same. So sum of 3 angles in a triangle is 180 degrees. So these two angles will be same. So that means we can say that in this triangle AMN, so if we consider this triangle AMN angle, so first we can see that angle AMN is equals to angle ANM. So that means triangle AMN is isosceles. So if this triangle is isosceles, so if I consider this figure for our reference, so we are having like AMN is isosceles. So that means like if we take triangle CBM, so we can also add this point. Triangle CBM is, yeah, so triangle CBM, so M is this point, so this is M. Yeah. So triangle CBM is congruent to triangle EDN. So that means, because like opposite to this angle, like we're having x plus y, and opposite to the same angle, like we're having x plus y as the side length. So those two will be congruent. So if those two are congruent, if I take some EN, let's say this EN must be equal to MC, and even this DN must be equal to BM. So that means if I take this thing as some, let's say some B, right? So if this is B, so this is some A. So this will be A, and this will be B, and this will be some A. So now like we're having, since this triangle like AMN, so we have seen that this triangle AMN is isosceles. Now if it is an isosceles triangle, so we have like AN is equals to AM. So that means A plus Y plus Z is equals to B plus X plus Z. So that means B is nothing but A plus Y minus X. And we already know what is Y and X value. So Y value is 4 and X value is 2. So that means this is nothing but A plus 2. So B value we got it as A plus 2. So if we replace like B is nothing but, so we are having B as just A plus 2. So that we have like only one variable to work on. So now if I consider this triangles, suppose if we consider triangle EDN, so we have like EDN, this small triangle. So in this triangle, if we take this angle, so this angle is 2 theta, this angle is 2 alpha, and let's say this is some beta being same. And similarly, if we consider the bigger triangle, so the bigger triangle is A, M and N. So here like we're having total length is A plus 2 and 6, that is 2A plus 8. And AN, if we consider AN, A plus Y plus Z, we know that Y plus Z is 7. So this will be A plus 7, and this will also be A plus 7 since AMN is isosceles. And we are having this angle as beta. So these angles are beta. So that means like we can find like this beta in terms of A in left triangle and also in the right triangle. So in the right triangle, we have like ED length. So the ED length is nothing but x plus y, which is nothing but 6. And EN length is, we know that it is a, and DN length is nothing but a plus 2. So by using that, like we can find like cos beta is nothing but a square plus a plus 2 whole square minus 36 by 2 times of a into a plus 2. And here, like if I draw the perpendicular, since it is isosceles triangle, this perpendicular will also be median, angular bisector, and it is also a perpendicular bisector. So that means this cos beta is nothing but, since it's a median, it will divide it into 2 equal halves. So that means this cos beta will be a plus 4 divided by a plus 7. So if we equate these two, we can find the value of a. And once we find the value of a, we can just find the area of the total triangle. And from those total triangle, we can just subtract this congruent triangles EDN and BMC in order to get the area of the pentagon. So we can solve that quickly. So this is nothing but a square plus 4a plus 4 minus 36 by 2 times of a into a plus 2. So that is nothing but a plus 4 by a plus 7. So that means this is nothing but 2 times a square plus 4a minus 32 by 2a times a plus 2, which is equals to a plus 4 by a plus 7. So that means a square plus 2a minus 16 by a square plus 2a is nothing but a plus 4 by a plus 7. So that means 1 minus 16 by a square plus 2a is nothing but 1 minus 3 by a plus 7. So that means 16 by a square plus 2a is nothing but 3 by a plus 7. So that means 16a plus 112 is equals to 3 times a square plus 6a. So which means we're having like 3 times a square minus 10a minus 112 is equals to 0. So if we solve this, a is nothing but 10 plus or minus 10 square plus 4 into 3 into 112 divided by 2 times of 3. So that means it is 10 plus or minus square root of 25 plus, so 336 divided by 3, which is 10 plus or minus 361 is square root of 3. So that means it is 29 divided by 3. So once we find the a value, so we can work out on the triangles. So sorry, this is 5 plus or minus 9 by 3. Sorry, so this is 5 plus 19 by 3, which is 24 by 3, since like our a can't be negative. So a, we got it as 8. So once we got the value of a, so we can see that the total area of the triangle, so total area of this triangle AMN is nothing but, so we are having 15, and we are having 24. So that means this will be 12. So that means half into, so we can find this length. So this length will be nothing but 9. So the area will be 2 times half into 9 into 12. So that is nothing but 108. So that is the area of this entire triangle AMN. Now area of the small triangle EDN. So area of the small triangle EDN is having the side lengths. So if we are having like a 6 and a plus 2. So since we got a as 8, so this is 6, 8, 10. So that means it is also a right triangle. So that means if we see this particular diagram, so we have area of this pentagon is what they asked in the question. So area of this pentagon ABCDE is nothing but area of this total triangle AMN minus 2 times area of this triangle EDN, because we are having like 2 such triangles which are similar, like EDN and BMC are similar. So this we got it as 108 minus 2 times area of this triangle 6, 8, 10 is nothing but half into 6 into 8, which is 24. So 108 minus 2 into 24, so that is nothing but 108 minus 48, which is nothing but 60. So therefore the area of this pentagon is nothing but 60. So that's it for this video.